A Rosie math teacher coming at you from my second period accelerated grade 7 math class, where today we're dealing with real numbers, two categories, rational and irrational. Guys, I want you to think of rational numbers. Imagine every area of this section, and I forgot to trace one of my little circles. Let me trace this little circle. There's a very specific category called natural numbers. It is a part of rational numbers, which are a part of real numbers. The categories you're most concerned with today are the categories called rational versus irrational. Rational, numbers that make sense, numbers that our brain can compute and understand very easily. And they can create a ratio, meaning they can appear as a fraction in some way. If they cannot be written as a ratio, they're irrational. My class has already written all of these categories down. We are ready to discuss. Class, wave at me if you remember learning how to count. All the way to 100. Do you remember learning how to count all the way to 100? I was so excited when I was in kindergarten and I learned how to count to 100. I used to count to 100 in the back seat of the car. 1, 2, 3, 4, showing off for my parents. If it's a number you would have said when you were learning to count, when you were a small child, it is a natural number. Is it natural to count from 1 to 100 when you're in school? Yes, it is. Natural numbers, any number you would say when you are counting. Then we go to the next category, whole numbers. It includes all natural numbers plus one more number, and I want you to write it on your paper right now as an example. It includes 0. We probably should put in the natural numbers category, it would include 1, it would include 2. So write those as 2 examples of natural numbers. Now, if it is included in the natural numbers bubble, is it therefore also a whole number? Yes or no? Yes. If it is in the whole number bubble, is it therefore also a natural number? Yes or no?
No.
No. So 0 is a whole number, but not a natural number. Do you see how the circles work? As they go out, they include a lot more. As they go smaller, they include fewer. So let's go to the next bubble. It says INT, which is short for integer. In the classroom, we wrote integers in this section. An integer includes any whole number, so it could still include 1 or 2 or 0, but it could also include, and here's what we're going to write, it could include -2, for example. Any negative symbol in front of a whole number is therefore also called an integer. So, class, is -2 also a whole number? Yes or no?
No.
No. Is -2 also a natural number? When you were a little kid, did you go -1, -2, -3? No, you never did. It's not a natural number. It's not a whole number. It is an integer. If it is an integer, is it also a rational number?
Yes.
Yes, you are catching on quickly. A rational number is any number that can be written as a ratio. So, for example, when I write 0.3 repeating as an example of a rational number, I am showing you that a repeating decimal could always be written as a fraction. Does anyone know what 0.3 repeating could be written as a fraction? Say it. 1/3. So class, go ahead and write that as well. Now, if they asked you if 0.3 repeating is a rational number, would you say yes or no? You would say yes. Would you have to rewrite it as 1/3? No. You write the number they gave you, but you know it is rational because it could be written as 1/3. Are we following so far? All right, so 0.3 repeating. Is it a rational number, yes or no? Yes. Is it also an integer, yes or no? No. Is it also a whole number, yes or no? No. Is it also a natural number, yes or no? No. It can only be the section that it is in or something outside of that. Do we follow? So nothing inside this section can be this. Irrational. Let's go over to irrational numbers. Irrational. Any square root of an imperfect square. I'll give you an example. Go ahead and draw yourself an example here of square root of 3. Now we learned in an earlier lesson that in order to be a perfect square, the square root must be a whole number. What, class, is the square root of 4? What is the square root of 4? Say it. 2. Excellent. So the square root of 4 equals 2. What is the square root of 1? 1. So I'll ask you this. Is 2 a whole number? Yes. Therefore, square root of 4 could go in this category whole number, couldn't it? Would it therefore also be an integer? Yes. Would it therefore also be rational? Yes. Would it therefore also be natural? No. When you're within a circle, it only includes that circle and everything going out from it. Are you understanding how the chart works? It never includes something in the middle inside of the section here, for example. This is why whole numbers include all natural numbers plus 0. Natural numbers, no 0. We good? Okay. So next let's talk about any decimal that never repeats nor terminates. I want you to draw an example here of the value called pi. It's a symbol, it's a Greek letter from the Greek alphabet, and the symbol is drawn similar to mine. It doesn't have to be perfect, but please draw that as an example. Here is why the symbol pi represents a number that is irrational. Because it never repeats. Hey, what did we learn about repeating decimals? Repeating decimals always have a fraction equivalency. If it has a fraction equivalency, that means it can be written as a what? Ratio. If it can be written as a ratio because it has a fractional equivalency, then we know it is a rational number and therefore not irrational. But if it is a decimal that never repeats, so no bar notation, and it never terminates, it never comes to an end, we're going to say, aha, that is an what? Irrational number. So pi is an example of that because it is 3.14. The numbers just randomly keep rearranging themselves and they go on forever and ever and ever, never ending, never repeating. If a number is like that, it is irrational. All right, I would like you now to please open to your textbook page that looks like mine. Please look at textbook page 116. Everyone in this room is going to page 116. We are going to quickly put each amount into the correct section of our chart. They give us -8. Please look at our chart. This is exactly the same as the chart that you just drew. And I want to know, raise your hand if you can tell us right away where we can place -8. Let me just quickly write nat for natural and write whole for whole numbers. My circles are terrible. Ignore how terrible they are. And write int for integers. And write rational, rational, for rational numbers. Inside this rectangle, and then inside my smaller rectangle, I have irrational. So irrat. You'll know what I mean. All right, -8. Tell me where it goes, ma'am. It goes in rational numbers, but it can go in a slightly smaller circle. Let me state this way. We want to put it in the most specific category that we can. Yes, it belongs in rational numbers. Can we give a more specific category, please? Integers. Ding, 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 ding. Everybody, please write -8 in your integer circle. So the person who said it is rational, are they still correct? Yes, because rational is the section outside of that. So negative 8 is both within the integer circle and within the rational box. Okay, now let us place negative 3. On the count of 3, tell me where to place it. 1, 2, 3. If you said integers, wave at me. Excellent, you are totally correct. Negative 3. And then our next amount, 3/4. Where shall I place 3/4? Raise your hand. Yes, sir. So, as it turns out, when it is a ratio that cannot convert to a whole number, so for example, if you were dealing with 4/2, class, what does that convert to? What's 4 divided by 2 worth? 2. So that would be an example of a whole number because 2 is a whole number, right? But the decimal, or I'm sorry, the fraction we're working with is 3/4. Can that convert to a whole number or a negative whole number? No, it cannot. So, do we have someone that would like to tell us where it's going to go? Yes, sir. Rational numbers. Excellent. So, class, please write 3/4 in the rational section. It cannot go in integers because integers only include a whole number or a negative in front of the whole number. What is the question? What's that? 3/4 is negative?
Yeah.
Oh, it's a negative 3/4. Thank you. Yes. So you need to copy negative 3/4 in front of it. Yes. So all ratios can be either positive or negative, and they still belong in the same section. Thank you for reminding me that I needed to fix that sign. Okay, so next we have 0. We already placed 0 earlier. Raise your hand if you can tell me where it goes. Yes, ma'am. It goes in whole numbers. Excellent. Not in natural. When you were a small child, did you count using 0? Probably not. Maybe you did. But it's not considered a natural number, but it is a whole number. All right, how about 18%? Now, class, I hope someone has taught you somewhere along the way that the percent sign means 1/100ths. If you have never learned that before, you've learned it just now. So 18% is equivalent to 18/100ths. Raise your hand if you can tell me where this goes. Yes?
Rational numbers.
It goes in rational numbers, exactly. Please write it as 18% since that is how it was given to you. All right, let's look at 0.4 repeating. I want everybody to tell me where that goes. On the count of 3. 1, 2, 3. It goes in rational numbers. 0.4 repeating. Why? Because we know if it's a repeating decimal, it will therefore have a fractional equivalency. All right, after 0.4 repeating, we are dealing with 0.45. Hey guys, this decimal terminates. Where will I place a terminating decimal? And wait, please read this to me as a fraction. 45 over what? 100. So therefore, we know it will go in what category, class? It goes in rational. Please put 0.45 in the rational numbers section. Next, we are looking at 1/2. 1/2. They gave it to you because it's a what? Ratio. Therefore, it only goes in the what section? Rational numbers section. 1/2. The next category we are looking at, I see a student that looks like they're writing nothing. Please be sure you are writing every single one of these items. All right, next we have the symbol pi. On the count of 3, say it to me. Where does it go? 1, 2, 3. Irrational. Great job, guys. Because it is a decimal that goes on forever and ever, never repeating, never ending. All right, after we finish with pi, we're looking at, ooh, this one's kind of long. It says 1.21234 ... What are they trying to represent there? A decimal that goes on what? Forever and ever. Is it repeating, yes or no? No. Is it terminating, yes or no? No. So where do we think I shall put it? Say. Okay, raise your hand if you vote for rational. Raise your hand if you vote for irrational. And that is the majority of the hands because you are correct. Class, please place that in irrational. 1.2, 1, 2, 3, 1, 2, 3, 4, dot, dot, dot. Mine barely fit. Almost not. We're good. Okay, next item says square root of 3. Hey guys, is 3 a perfect square? If you square root it on a calculator, does it give you a whole number, yes or no? No. So, not a perfect square. Where shall I place it? On the count of 3. 1, 2, 3. Okay, raise your hand if you vote for rational. Raise your hand if you vote for irrational. That would be correct. Irrational. Majority got it right. Yeah, guys. Great job listening. Great job participating. Square root of 3. Not a perfect square. In order to be rational, it has to be a perfect square. An imperfect square will have a decimal that goes on forever and ever, never ending, never repeating. Next up we have 4. So please write 4 where you believe it should go. On the count of 3. 1, 2, 3. Natural. Who said natural? Wave at me. And let's go ahead and put the other 2 numbers they gave us. Where do you think those 2 numbers, 9 and 10, also go? Natural. Let's just put all 3 of them in there now. Now, class, I have one more special item I have just for you. Are you ready?
Yeah.
Please think about where this would go. Wait till I finish drawing the whole thing now. Okay? I'm going to draw it in really big writing so it's easy to see on the TV screen. Stare at it for a moment. I just wrote square root of 5 divided by square root of 5. So you have to figure out if it's going to be rational or irrational. I would like us to do a vote. Keep your hand up if you think rational. Keep your hand up if you think irrational. Now, in this particular case, and it's okay guys, it's a little tricky. Correct response was rational. Can this young man tell me how he knew? You should be able to tell by looking at it. What have we learned in the math world about what it is called when your numerator piece matches your denominator piece? It always equals the whole number. Who agrees it equals the whole number 1? So you know that square root of 5 over square root of 5 would equal 1. Therefore, it would go in the section called what? Would actually go in natural numbers. I can't fit it. If you can fit it, you may put it there. But at least you learned about it so you won't be confused later. All right, for today's homework, I hope all of this was a big help. I want you to get busy right now.